All right, recording. All right, so good afternoon, everyone. Um, okay, I guess I could get right into it. This is one of the first events we are holding in our new cloud AI community. Okay, more and more people are joining in. All right, this is the first event we are holding in our new cloud AI community. I mean, the cloud community in GDG OAU has been existing for quite some time, but you know, if you really think about it, we have not been as active as we are meant to have been. So this event is just one of the first of many that we are using to rejuvenate the cloud spirits in GDG OAU. And we have a wonderful speaker with us today, Mrs. Eunice Adediran. She's an industry expert. But before I hand it over to her, I think I just need to give you guys a quick rundown on, it's just more of like an introduction to the new community. That's for those of us that are not yet on the community group. Can I get reactions, please, to make sure you guys are hearing me clearly? All right, all right. Straight to it is this session is getting started with cloud, and I'll have you guys know that like cloud is you can think of cloud as the engine driving the AI revolution in the sense that models, running models, training models, scaling or deploying them and whatnot is something that like you need cloud infrastructure to do. And if you think about it, ChatGPT, can't remember the metrics, but it was like one of the fastest apps to get to 1 million to get to 1 million concurrency users. And if not for proper infrastructure that they handled it, the app would have crashed several times. I mean, back in the glory days of OpenAI of ChatGPT, you would always go in and use something like ChatGPT is not available at the moment because of the amount of traffic they were getting to it. But that's mainly they were only able to handle that amount because of the had proper cloud infrastructure in place. So, you can, it's not even just ChatGPT. I don't need to put too much into this, but, our speaker will handle this for you guys. But it's just safe to say that cloud is a very important domain. All right. Another thing is I held a poll on the group to know what our level of familiarity with cloud is. I held multiple polls. I got the majority of people mentioned having heard about cloud, but not knowing more about it. So it's kind of like the session will give you an introduction and everything you need to get started is basically. So okay, like I mentioned, this is the cloud slash AI community. I mean, cloud itself is a very, very wide domain and training AI may be, guys may be wondering how this is going to work out. But basically, there is the core of cloud, which entails DevOps, cloud native development, infrastructure, and all those complicated uh complicated parts of cloud. But then again, there's also an intersection between cloud and AI, like I mentioned about holding infrastructure. And there's two parts where um running AI models is too expensive to do locally. The best way to do it is to, run it through cloud services. There's Google and a bunch of others. So what can you expect from this community? Well, the main things I can like that this community has to offer is, in this domain of Google Cloud and DevOps, will help you guys familiarity with. Okay, let's just say this is what we are going to be doing in this community. This is what this community is going to be defined by, basically. first and foremost, the most important part of this community is going to be the Google Cloud and DevOps. We are going to get you guys familiar with the Google Cloud Console because that's what most of uh most of the work of cloud developers, especially using GCP, is going to be involved in. And then, we are going to touch on DevOps, automated CI/CD pipelines, containerization, system architecture. Don't worry, it's understandable if you guys don't know any of these things I'm mentioning. Our speaker is going to shed more light on it. But yeah, our core part is going to be Google Cloud and DevOps. You know, all these things may seem complicated, but it's something you come to learn and understand very, very soon. Also, I've mentioned this before. This is only the cloud sub-community from GDG OAU. That means there are other tracks involved. There's track for web development, there's a track for mobile development, there's a track for machine learning, data, game dev, cybersecurity, and all other tracks. So another thing we're also going to do in this community is, exploring the intersection between cloud and these other communities. We could host joint workshops, joint hackathons, and we will also work on projects along with these other communities. So that's something you guys can look forward to. Next up is AI labs and technologies. So as you guys know, there's always one new cloud AI tool or feature coming out, and it might be very difficult to keep track of them all. So another thing we are going to be doing in this community is getting people in, like just who demystify the latest, not even just from Google, like but mainly centered around Google, but we demystify the latest cutting edge tools, and we're also going to focus on Google's AI labs, which contains just fun experiments by Google um before they are launched to the public. There's Google Flow for generating videos, Sound for music and design scoreboards and all sorts of things. So, it's going to be very interesting to try those out. Another thing is cloud events and webinars. So, like I mentioned, GDGOA is going to be hosting a event next month with AI. It's going to be a flagship event on OAU campus for those that are going to be around joining. And we are not just going to stop at physical events. We are going to be hosting digital webinars just like this. We're also going to be doing live parties of the main Google and Google Cloud events that they are hosting, and we'll also be dropping recordings and summaries on our YouTube channel. So that's just something you guys can look forward to. So okay, this is only the start of the meeting, but I'm going to be dropping these links in the chat for anybody interested, to join our WhatsApp community. We'll also be exploring Google Cloud Skills Boost. It's a way to actually learn about cloud and cloud technologies. And then there is the Discord channel for Google AI Labs. And um okay, there's Discord channel for Google AI Labs, and there will also be the link for us to register down for Build with AI. And I'll also drop the link for our YouTube channel. You guys don't need to worry about this. I'll drop all this in the link in the chat. But the most important one is for you to join our WhatsApp community so we can update you and give you steady updates about our progress and everything. And with that, I think I would like to call on our speaker for today. Um, I don't, maybe I'm not supposed to be gassing out for, but I met the speaker on LinkedIn. I saw, I was seeing so much of her activity, and I was really just amazed, and I was really just wowed, and I just felt this is someone that I have to get on a call with. Like, this is someone I need to bring to and introduce to our community. So without further ado, I would like to bring in Eunice Adediran, a DevOps engineer. Please, you guys can react with some clapping emojis or something, please, just to job. But she's a DevOps engineer, AWS, Azure, GCP, Kubernetes, Terraform, you know, everything. She really has everything, and her focus is breaking cloud into real world systems. So let's give it up for Eunice Adediran.
Okay. Thank you so much, Joseph, for that introduction. And yeah, so good evening, everyone. My name is Eunice. So let me share my screen. Just let me know once you can see my screen. Okay, please confirm you can see my screen. Can you all see my screen? Okay. All right. Thank you so much. Okay. Good evening once again. My name is Eunice, and I'm a DevOps and cloud infrastructure engineer. Today, I'll be talking about cloud computing beyond the buzzword. I know a lot of us would have probably been hearing about cloud computing, and we just really want to understand what that really means, right? So today we'll be talking about cloud computing, understanding the technology powering modern applications, different cloud niches, right? And if you have any question, you can just raise up your hand or just drop it on the chat and I'm going to pick it up. All right. So uh today we would like to cover practical jargons, right? Free tour of the cloud. What cloud computing actually is, what does it entail, right? How it powers apps you use every day, right? Because we all use different applications every day that are being powered by cloud. So why businesses choose the cloud, and cloud carrier paths and what they do, because of course we do have different cloud carrier paths and what each of them, right, what they do. Also, I'll be covering major platforms, different CSPs like AWS, Azure, and Google Cloud Platform itself. Also, I would mention real industry tools, day-to-day tools that a DevOps person can't do without, right? Your beginner roadmap to getting started into cloud journey and the future of cloud plus AI, right? So if you can hear me, just give me a thumbs up. Just want to be sure. Bear with me. Okay, thank you so much. So first, I would like to start with my cloud journey. I started as a QA engineer, then I pivoted into cloud infrastructure. You know, testing software, understanding how system breaks, giving customer more seamless user flow experience. And moving forward, I pivoted into cloud, right? I got curious about what's really behind infrastructure. So back then in school, I took a course around cloud computing, and since then I've been a bit curious to know what's behind it. Cloud. Okay, I know cloud is the cloud when I look up or something else entirely, right? Then fast forward, I joined the ALS cloud program, and I became the Nigerian squad lead, right? I was preparing for my cloud practitioner certificate and my associate certificate. Then I was able to like get my certification and also other certificates, right? Then I started building built-ins in the cloud. But this doesn't mean that that was my first approach, right? Of course, I was building and at the same time I was getting my certification along the way. And now I work as a DevOps and cloud engineer. I work around tools like Kubernetes for orchestrations, right? And Terraform for IAC. I use CI/CD, GitHub Actions, Azure CI, GitLab CI, Vaults, Observability, working with these tools every day, basically. So I have a quick question for everyone. So, have you ever used Netflix, Google Maps, or WhatsApp today? Of course, WhatsApp. I know every one of us must have used WhatsApp today. Yeah. Thank you so much for that reaction. So then you've already used the cloud, right? You've already used the cloud. So what is cloud computing? I want us to think of it in this manner. Think of it like electricity, right? You don't build your own power plant. You plug in and use what you need, paying only for what you consume. You necessarily don't have to own a power plant, right, for you to have electricity. Some of us use meters, right? So cloud computing is the same idea. Instead of owning servers, right, storage and networking equipment yourself, you rent them from a provider over the internet and use exactly what you need. And that's why today we have different CSPs. When I say CSPs, I mean different cloud service providers like Google, Amazon, Azure, Huawei Cloud, and the likes. So also, I would like to say, I usually say that I see cloud more as a different planet, right? Just the same way we have the Earth for humans, animals, and we need a lot of things for us to survive, right? As a human, the same way I see the cloud, because over there, the application needs compute, storage, networking, a lot of things for them to survive, the same way we are on the Earth. So, and that brought me to the three core building blocks, which is the compute, right? That's the virtual machines and processing power. Every one of us on this call, we have a laptop, right? And that appears to be more like a physical machine where you do your own thing, your day-to-day activity, whatever you want to do. And for that, you need, for some reason, you might say, oh, I need my laptop to be much more faster. I need different kind of, okay, I want to increase the memory, or you want it to deliver more of what you do, right? Also, the same thing as storage, files, database, backups, and the same thing as networking, connecting everything securely, making sure your application runs the way it's supposed to. And also, we have traditional servers versus cloud. I'd like to explain the difference between them. So why the world is moving from physical data center to cloud infrastructure, right? We have traditional, or we call it on-premises, then we have the cloud infrastructure. So for traditional on-premises, right, you buy and own expensive hardware upfront. You basically have to buy them upfront, those servers, right? But in the cloud, you really have to just pay only for what you use, no upfront cost. You can basically just say, oh, I need Redis, I need a EC2, or I need this, and you just spin it up, unlike the on-premises, right? Also on-prem, right, it takes months to set up new servers. You have to make sure everything is in place. You have to do the necessary things to keep the server running. But in the cloud, right, you can spin up new server in minutes. You can just go in there, log into your whichever cloud provider you're using, either Google or AWS, and spin up your instance, right, in a minute, right? So scaling up also, for on-prem, scaling up means is equals to you have to buy more physical machines for you to scale up. Unlike on the cloud, you can scale instantly up or down. We have different kind of scaling. It could be vertical or horizontal scaling. On-demand scaling can enable auto scaling that, oh, when I have more traffic, I need more instances, or I need more of this on. And when we don't really have much traffic, you can basically just scale down. Right. So on-prem as well, you are responsible for maintenance and repairs. You have to be responsible for that, for those machines. You have to be responsible for the maintenance. You have to be responsible for the repairs and every other thing. Right. So, but in the cloud, right, provider handles maintenance and hardware. AWS is not going to reach out to you and say, oh, we want you to help us to maintain this. No, they handle that part of things. The same thing with Google, right? For on-premises as well, unused capacity sits idle. You're just wasting money. You just have those servers there. They're not really doing anything. But then it's on-prem, right? You own them and you have to cater for them. On cloud, right, you optimize for costs and eliminate waste. Whichever resources you don't need, you just have to take it out or scale it down and spin it up whenever you need them, right? Then for on-prem, you have more like a single location, no disaster redundancy. And if even so for this, right, if something happens to a particular region of your you don't have like your DC, like you don't have a DR, that is going to like affect a lot. But on the cloud, right, you have global regions, built-in disaster recovery. If something happened to a particular region, you can actually route your traffic to the other region, right? So the next slide is talking about cloud powers apps you use every day. I want to believe majority of these apps here, we use them, like Netflix. Some of us even watched movie overnight or something. It has like 236 million plus subscribers. You know, you're streaming videos, you're watching. A lot of things is going on behind the scene, right? That you basically don't know, right? And this, all of this is being powered by the cloud. So we also have Uber, where AWS on AWS or GCP, you know, real-time location tracking and matching algorithms, all of this cloud powered, right? We also have WhatsApp. We all use WhatsApp, like 2 billion messages, you know, you're sending message to your friend, getting delivered, you know, media storage, encryption handled by cloud, everything handled by cloud infrastructure. The same thing with Spotify, right? Jumia, fintech apps. Some fintechs uses different CSP, right? Some uses Azure, some uses AWS, some use Google, right? Payment processing, fraud detections, and compliance infrastructure, all cloud native. So this is why every modern business uses cloud. Like, why do they actually use cloud? So the first thing here is speed, right? Launch products in weeks, not months. Provision infrastructure in minutes. We don't need to like wait for servers, right? It's there. You can either use ClickUps or use your IAC. Okay, I think someone is raising up behind. Okay, you can't see my slide. Really? Okay, Joseph, you can see my slide as well.
I can see your screen. Can you go back to the slide? Let me see. Confirm that. Yeah, it's showing. The slide is still displaying.
Okay, someone dropped it
Okay,
on
you
the
can
chat that I
see
can't see well. Okay, I think this is okay.
network
Can you
issue.
see it now? Maybe it's your network really. Can you confirm if you can see it now?
Yeah, try to
Okay.
rejoin. It's back
All
now.
right. All right. I think it's your network. All right. Sorry about that. Okay, so as I was saying, right, speed, you know, launch products in weeks, not months, provision infrastructure in minutes. You can use the infrastructure as code like Terraform, right? To provision, can use ClickUps, whereby you just go to the GUI and you start to like spin up whatever you need. Then scale, I mentioned this earlier, you know, handle like 100 users or 100 millions infrastructure adapts automatically, right? You have your auto scaling enabled, whereby it scale up when necessary and it scale down when it doesn't. Then we also have cost efficiency, you know, no upfront capital. You pay for what you're using, pay as you go. Means you only pay for what you use. You don't have to pay for, excuse me, you don't have to pay for what you don't use. And also security, you know, what class security team at AWS, Azure, GCP protect your infrastructure. You don't need to panic, right, about security. Then reliability, you know, built-in redundancy. If one data center fails, you know, traffic reroutes automatically to the next, right? Innovation, you know, access AI, ML, analytics, and IoT, Internet of Things tools, without you having to build from scratch. Okay. So so far, any question? If you have any question, you can just let me know before we move to the part two. You can just raise up your hand and or give me a thumbs up if you're cool and we can proceed. All right. Okay. Okay. Then let me proceed. So the part two is talking about, I'm going to talk about the cloud ecosystem, the platforms, career paths, and real tools, right? I'm going to mention a few of them on this call today. So the three big right cloud platform, right, you encounter most in the industry, AWS, Azure, and GCP. So AWS is the Amazon Web Services, right? It's more like the widest service catalog, 200 plus service, large community. They have great certification track. Same thing with Azure, best for Windows, Office 365 shops, Active Directory integrations. It's great for fintech and banking. We have GCP, best AI ML service, Kubernetes leader, BigQuery for analytics, Google's own infrastructure. So I know you must have probably come across these different cloud providers before. And yeah, so there are quite a lot of them. We have Huawei Cloud and a lot, right? So this is more like the cloud career paths. So there isn't just more like a single job in cloud. It's cloud is more like an entire ecosystem of different roles. So we have the cloud engineers, they basically design and they build and manage cloud infrastructure, provisioning server, set up network, manage storage, and the likes. Then we have the DevOps engineer. So the DevOps are basically bridging the gaps between developers and operations, right? So they build CI/CD pipelines. CI/CD pipelines means continuous integration and continuous delivery. So when they are done writing their code, right, of course it's in their local machine, and they can't really start carrying their machine up and down and say, oh, I've built this application, right? Come and see, it's working. Localhost 5,000, localhost 8,000. My application is working correctly. You can't really give that to somebody that is in the US or UK and say, oh, come and look at my machine. My application is working. So CI/CD pipeline, more like continuous integration, continuous delivery pipelines. You could use GitHub Actions, GitLab CI, Jenkins, and the likes to automate deployment processes so that when a developer raises more like an MR of a new change and they need to like deploy a new feature, all of this is automatic. They necessarily don't have to call, oh, I need to make a push, because the pipeline is already there and it gets triggers immediately when they raise their code changes. Right. So we have the SRE. Those are the site reliability engineers. They help to keep system running at scale. They get on call, incident response performance. They monitor the system, and if there is maybe any escalations, they get on it real quick to make the system more reliable. They make use of different tools. They make use of on-call. They make use of New Relic, Grafana, and the likes. A lot of them, right, as well. Then we have the cloud security engineers, protect cloud structure, IAM policies, compliance, audit, vulnerability management, implementing the best least privilege principle. Then we have engineers, right? They build internal um, developers platform, abstract infrastructure complexity, so dev teams move much more faster. Then we have the data engineers. They build data pipelines and cloud data warehouse, ETL, streaming data, analytics infrastructure, and the likes. Okay, so what does a DevOps engineer actually do? Like a real look at daily work. What's like a day-to-day activity of a DevOps engineer, right? So this time I actually changed based on your company, right? I just have to like put this here. If you're running like 9 to 5 based on your job description, it's might change a little bit, but look at it more like the CI/CD pipeline failures, like a deployment pipeline broke overnight or something. Developer is trying to like make a code change and push it right over there. and then the pipeline breaks or it fails. It could be different things. It could be maybe from the developer's code itself. It could be maybe one of your configurations or token has expired. It could be a lot of things, right? So you check the logs. Maybe you're building your Docker file. The pipeline breaks at the point of building Docker file. You check the error because, of course, it will be there. Then that would help you know to see that, oh, this is actually what's going on, right? Then identifying the failing steps. So for pipelines, you have different steps for your pipeline, call it jobs, different jobs, right? So you check at what step is this pipeline failing. Is it at the point of running your check marks or security scanning tool? Is it at the point of building your Docker file? Is it at the point of pushing your Docker file to ACR or whichever container registry you're using? Is it at the point of deploying using your GitHub tools? Right? You try configurations, then infrastructure code review, right? And so in a system, in an environment whereby you're using IAC, maybe Pulumi or Terraform, most company uses Terraform, like uses Terraform. So there's also a lot of other infrastructure as code, right? So a colleague wrote like a Terraform code to add more like a new database or a new module entirely. So you have to review it for security and best practices, or maybe you're the central manager of your modules, like your Terraform modules. You know, you have different modules that handles different resources, and someone is trying to say, oh, I want to make a change to this particular module, or I'm trying to like add a new vault to this. Of course, you have to check your Terraform plan to see that is this going to break anything. So there's a way Terraform has plan and it has an apply, whereby your plan will help you see what you're about to apply. So if it destroys something or something in place, of course you're going to see. And if it's something you have to like take back to say, oh, I need you to look into this, or what is this? Is this action intentional? Are you actually trying to destroy these resources, or this is more like an oversight, right? So you can raise that, and both of you come to an agreement to say, okay, yes, this is what I'm trying to do. You review the security aspect of it and best practice, making sure that there is no maybe your flying keys or password everywhere, right? Those are not best practices. Then also incident response, alerts, API latency spike, or open Grafana dashboards, trace the cause, escalate or fix it. So maybe you're using Grafana, company might be using Grafana. Grafana is basically for visualization of your logs, your metric, and the likes, or you're using New Relic. It's like check through, trace the cause of the issue. When is this? Or download the logs to see, what's actually going in here, right? And look for the fix to that. So security audit gap as well. You tend to like review IAM policies and access logs ahead of compliance audit, because yes, you have to document your findings. Maybe you're over giving somebody that does not really need that permission, over giving your maybe team members like, why are you having this permission? You don't need it, right? So you have to like review that. Then platform improvement, there might be some manual stuff that you do. Maybe when you're trying to like create a new service, you have to start writing the Terraform modules. You have to start doing all of those things from scratch, create a service on Argo or whichever, right? So you can now start coming up with innovative, like, oh, I need to start writing scripts, right, to do all of this manual work, right? Then also script to automate certificate rotation that maybe takes 2 hours manually. You can just write a script to do that. Okay, any questions so far? Are we still together? Just give me a thumbs up. All right. Okay, thank you. So real tools used in the industry. So for me, tools I used in production today and what they're basically used for. I think I've mentioned some of them, but then yeah, we can really talk about it. And if you have any question, right, you can just raise up your hand and ask, right? That's fine. So the first one is infrastructure as code, right? We have Terraform. Terraform writes code to provision cloud resources. So some people use ClickUps, but then in organizations, right, ClickUps is not usually advisable because you might not be able to like keep track to what you're changing and what is changing. But if you're using Terraform, Terraform becomes your source of truth for everything. You know what's in there in the cloud. So if something is not in line or somebody has changed something and provision, Terraform is going to detect and say, okay, I'm going to destroy this, or this is not in my state file. So Terraform has its own state file, and really, I see it's more like Terraform DB that kind of keep tracks of whatever it's been provisioned. So if you delete any resources that it's been provisioned via Terraform manually, it's going to cause a drift. Or you are editing what Terraform provision itself, you're trying to like make an edit to that resource, it's going to cause a drift. Because by the time you're trying to like apply your new changes, there's not going to be more like a consistency with what you have with your state file and what is on your dashboard. I mean your cloud provider. There's not going to be consistent, and that's going to cause a drift, right? So we have Pulumi as well. Pulumi is more like a general purpose programming language. You can also use Pulumi to provision your infrastructure and the like. So containers and orchestration. We have Docker, it's package app into portable containers. You package it, they call it, you have your Docker file. So for every deployment you're trying to like work on, of course, you have your Docker file that houses your, you have the wrapper and your application itself. So it's Dockerize it, it's package it together, right? Then you have Kubernetes. So Kubernetes help manage and scale containers at scale, really. So there's a lot. Each of this is more like a topic on their own, but for the purpose of this training, we are just trying to keep it simple, right? Then we have Argo CD. Argo CD for GitOps based continuous delivery, meaning that, for example, your developer make a code changes, right? You have your pipelining checks. It could be Azure pipeline, it could be GitHub Actions or Jenkins. It picks up those changes immediately depending on your branch strategy or branch that you've set up. Okay, I need this pipeline to pick up when there is a merge request to this particular branch, which is your default branch. It could be main, right? Then it builds, do the necessary vulnerability scan, do the code analysis. You might be using SonarQube. There are a lot of tools that you can integrate to your pipeline to make sure that you have the best implementing practices. You can implement check marks for scanning as well. For code analysis, you can use SonarQube, right? There's ZapScan, a lot of them, right? So GitHub, Argo CD helps with the continuous delivery. So when there is a merge request, you merge your code, you build your pipeline, your Docker file, build it, push it to the ACR, your container registry. Then you have your MSD, that's your microservice delivery to the Argo CD, and then you have everything over there. So you can basically visualize what's running on your cluster inside from your Argo CD. So it helps you see, oh, this is the number of pod running, this is my deployment, right? And when you probably have a new release or feature you want to do, you can as well handle that from the Argo CD side of things. It also helps you like avoid over permissioning. So people, not everybody have access to the cluster. Whatever you want to do, you want to check logs, you can actually see that from the Argo CD because Argo CD has that feature, right? Then we have the CI/CD, continuous integration and continuous deployment. That's I mentioned GitHub Actions, right? Automate, build, test, and deploy. So based on your jobs, based on your pipeline steps, GitHub Action is going to execute them one after the other. Either you're using a consolidated repository or you're using more like an organizational workflow that you're just making reference to each of those workflows in your repository. The way you structure your repo, right? It speaks way. And we have Jenkins, that's more like a flexible open source CI/CD server as well. So you can actually choose. You can choose to go with Jenkins. You can choose to go with GitHub Action, whichever. Then, okay, I think someone is saying something. Obina, do you want to ask any question? I can see that you.
Might be a glitch.
Okay. All right. Let's move forward then. Okay, so we have observability, we have Prometheus, for collecting metrics from application. You have Grafana, like I mentioned earlier, visualize metrics in the dashboard. So on Grafana dashboard, you can actually see the metrics, the logs of your application. Then we have Datadog. It's more like a full stack monitoring platform. It has every component embedded in it, and you can actually do setup alerts and anything you want to do in there as well. We have security and secret. So for AWS, we call it Secret Manager, Also, Google has their own Secret Manager. We have HashiCorp Vault, right? We have AWS IAM for controlling who can access what in AWS, right? So you don't want to give everybody a like an access to do whatever they want to do, right? You can actually limit their access, their permissions from that leg. Then we have version control, we have Git tracks and manage code changes, right? Git is something you can't even do without, really. You can't do without it. And then we have GitHub, it's help host code and collaborate on projects. We have GitLab as well, right? That does the same thing. Okay, so this is more like a beginner roadmap that I try to work on, right? So this is a more like a practical step-by-step guide to breaking into cloud from zero to at least being employable, starting from more like an internship, because that would help you like gain exposure to real world problems and see how all of this integrates together. And sincerely, you might not even use all of those tools. It's just based on what your company is going with. Some organizations chooses GitLab over GitHub. Some uses Terraform. Some are using Jenkins. It's just based on your company, right? But then foundational level, like don't my advice has always been don't skip the basics, because really you need them, right? Some people just hear, oh, I've heard of Docker, I've heard of containerization, I just want to jump into Kubernetes and start learning Kubernetes without really understanding some of this foundational basic knowledge of what's going on in there. So you learn Linux fundamental, command lines, your little ls, cd, all those bash scripts, right? You learn basic networking, what's an IP. I've been hearing of IP. What's even an IP? What's DNS? A lot of us today, we just go to the internet and say www, or just mention jumia.com and you're there, just bringing what I need. You really don't understand what's going on behind the scene to this thing. All of these things are not magic, right? Something is definitely going behind the scene that you don't know. But because we are just used to giving a tap over something and it happens, you're like, okay, yeah, it should work that way, it should work. But then something is actually making it work, right? Then Git and version control basics. Git is very, very, very important. I've seen situation whereby you'll be battling Git, people battle like Git conflict, right? You don't know how to like resolve it. So Git is something you can't even play with. Git is something you can't even do away from it. You actually need Git. You want to push your code, because of course you can't keep whatever you're building on your local machine. You have to push it out there, right? So the second part is, I think you can take like 1 to 2 months, depending on how fast you can learn and how serious you are with your journey on getting started or picking up this cloud, right? You can use like 1 to 2 months to learn this, understanding the basics. Try to know why. Okay, why is it that if I press google.com today, I can see Google page. If I go to jumia.com today, I can see Jumia page, right? All of those, there's something behind the scene that you don't know. Then the second part is more like cloud basics, create GCP, free AWS, GCP accounts, Azure accounts, you know, start breaking things. For me, if you don't break, you don't learn, right? But if you take your time to troubleshoot an issue for like 5, 6 hours, if they tap you maybe a few months later and say, "Oh, I'm having this issue," you would definitely know what to do to fix it. But if you're like, "Oh no, I'm just waiting for that I just want to stay. I don't want to break anything," right? Of course, you're not going to learn. So core services like compute, storage, networking, and your SAT. But sincerely, try as much as possible to learn what you're trying to be certified for. Don't just go for the certificate, right? You can go for the certificate, but then don't just get the certificate for the purpose of getting it without understanding the systems or the logics that work behind the scene of that certificate. Because the truth of the matter is you can actually get your certificate and truly not understand how all of this works. I identified this gap, and that's one of the reasons why I started breaking cloud into simple terms. That's basically what I do. I try as much as possible to do that. So try to understand this. You can create free accounts on all of these CSPs. You can choose one, right? You necessarily don't just have to go across all and say you want to learn all at the same time. No, because when you understand the basics and how all of this work, it's not going to be it's not going to be difficult for you to apply the same principle across board. Each of these CSPs has names, just a name to differentiate them. So GCP we say virtual machines, instances, AWS we say EC2, right? The same thing with Azure. So you can just pick one and start learning from that platform. Try to understand, okay, what is compute, what is storage, what is networking, how can I host my first application? It does not have to be something big. It can just be, oh, hello world, my name is this. Oh, hello, my name is that. Just you deploying it and understanding, okay, I see why this is like this. I see why this is like that. Then automation, you pick one. You can learn Python or Bash scripting, right? You can pick one, either Bash or Python, right? Then Terraform for infrastructure as code. You start to understand how Terraform works, basic Terraform commands, Terraform init, Terraform FMT, Terraform validate, Terraform plan, all of those commands. You learn them, right? And you try to understand you can start as little as you just creating your first main.tf and creating your just having a single main.tf, local.tf, and from there you graduate to modularization where you just have to start calling modules, and from there you graduate to taking the official all of the CSP cloud modules, right, to provision whichever resources you're trying to provision in the cloud, and from there you move, right. Then GitHub Action for basic CI/CD. GitHub is free, right? You can just open a GitHub account, set up your first GitHub action. It could just be a simple application, right? Set up your first GitHub action, see how GitHub action works. Okay, what's even these GitHub actions? It could be just a two-step, right? And you're good to go. Then Docker, like I mentioned earlier, to build and run containers. Then you have Kubernetes basics. Kubernetes is very, very broad. But then there are basics of it that you can understand. What is pod, what is service, what is deployment, config map, all of those, Kubernetes networking. You can pick all of those and try to like understand what it actually means, right? Then deploy a real app end to end, and just pick up an application and deploy it. Or if you have maybe a backend or a front end developer, just say, don't worry, let me just help you set up your pipeline, and you learn from there. It might not really be money from the beginning, but trust me, when you have that experience, when you have that exposure, when you understand what you're really doing, you will stand out. That's the truth. Then we have free resources that you can get started with. We have the Google Cloud Skill Boost. We have the AWS Skill Builder. The Linux Foundation has a lot of free courses. I also make some posts on LinkedIn about real life cloud scenarios and articles, right? You can go in there to read and drop a message, or you can send a DM to probably ask me questions if you don't understand it. I also have a YouTube channel. Then there is Step Up with Nana. You can check out as well. There's Abhishek. A lot of them. Just go on YouTube. A lot of them, right? Cloud Resume Challenge. There are a lot of challenges. I think I've seen DMI on LinkedIn. It's just you trying to, like, some people say 30 days DevOps challenge. Opt into that. Try to, like, you might not be able to, like, pick up at that speed, but then you're learning. So don't rush it. Try to, like, understand what you're doing and not just doing it. That's just the key. Then have, like, some cloud programs that you can opt in for to understand it better. So these are, like, common mistakes beginners makes. Okay. I think somebody is raising up their hand. That's Felix, right? Am I correct?
Yeah.
Yeah, Felix.
So about
You can go ahead.
Linux, is there a specific operating system that you'd suggest for someone that's just starting cloud?
Really, you can use anyone just to get started, right? It does not have to be more like a particular specification. So when I started, right, I'm not advising you to do this, but this was what I did. I was doing partitioning. So I changed my OS to Ubuntu just for me to, like, have that feel. Then before I started using Mac, right? But some people, they are much more comfortable with Windows, whichever works for you. But then for me, I was much more comfortable with Ubuntu. So I just changed my OS and I have that feeling you get. So hope that answers your question.
Yeah.
All
Thank you.
right. Okay. So these are common mistakes beginners make, right? And this is something I've seen, like yeah, they just tend to, like, hear that term and say, oh, cloud engineer, and they're going for it. They really don't understand what it's all about. Okay, what is an IP? What is DNS? And funny enough, you're using all of these things every day. You can relate your real life, what you do every day, you can relate it to cloud. I think there was a time I made a post around VPC and subnets, private subnets, public subnets, VPC, and the likes. You'll be hearing terminologies like load balancing, auto scaling. You'll be like, what is all of this? But sincerely, these are the things that you do daily. Because I want to believe every one of us used to go to the supermarket, or you're just in a point, but maybe you want to buy fuel or something, right? And you have that queue there. And there's this man that will be standing and say, oh, this queue is too filled up, just move to the next one. That's more like your routing traffic, right? That's load balancing. You don't want to overkill a particular cashier that is taking up your request. I say, okay, bring in your cards, let me check what you're doing, because you can spread it across, right? So that to make things faster. But then if you don't really relate this with what you do physically, your day-to-day activity, you see it as, oh, this is a big term. I can't even understand it. But what is auto scaling? What is VPC? What is a subnet? What is IP address? What's DNS? What does that mean? But you're using this thing every day, right? So I want you to learn from this now, so you don't have to learn you don't have to learn them the hard way, really. So number one is trying to learn everything at once. I know the internet can be so confusing. You see this one say this today, this one is saying another thing tomorrow, but you have to define what you need to do. Learn something. Just pick. If it's a single cloud provider you want to pick and learn about, pick it. Don't open this cloud provider, open this one, open that one, say you want to learn the three at once, because yes, you want to be multi-cloud provider, that and the likes. You don't need to do that, really. You just have to pick one and learn it. That even if they tap you and say, oh, I want you to spin up EC2 instance, or I want you to spin up an instance on Google, do this, do that. Oh, I want you to help me profile a secret, right, on Google Secret Manager. I need you to help me check the Kubernetes cluster or the Cloud Shell to see what's going on in my cluster or something. You know how to go about it. So my advice is, don't learn everything at once. Pick up one and learn. If you want to take 2 months or a month to learn basics of Linux, take it and learn it. Take courses, YouTube tutorial, just Linux. You might be saying they will suggest Kubernetes, they will suggest Docker. Leave it aside. Just focus on that one and learn it. Then when you're done, you can move to say orchestration or Dockerization. You pick up Docker. What's Docker? You can set up your Docker desktop on your laptop. Try to understand what's Docker. Build your first Docker file. Wrap an application, deploy it, containerize it, run the Docker, compose, whatever. Try to understand it perfectly. They will suggest other videos of, learn this, learn Nago, learn Pulumi, learn this one, just learn it. The same thing when it comes to IAC. If it is Pulumi you want to learn, pick Pulumi. If it is Terraform you want to learn, pick Terraform. But don't try to put everything at once and say you want to learn everything at once, because sincerely you end up not learning anything, right? So pick one cloud, one skill, go deep before going wide. That's my advice, right? Just pick one and master it. Then skipping Linux and networking fundamentals. You see, if you don't understand networking, you're going to troubleshoot a lot of unnecessary things, right? Because you say, this thing is not working. I'm trying to ping the address, it's not resolving. The DNS is not resolving. This one is not working. Oh, I cannot access my application. The URL is showing 503. The URL is showing 504. I'm getting 502. Bad gateway. All those error codes. Imagine you're trying to call an endpoint and you're saying, or test an endpoint and you're getting 404, not found. But if you don't understand all of this, you start troubleshooting what is not even necessary, right? Or you're building your Docker file and the thing is breaking and it's pointing you to, this particular variable cannot be empty. This cannot be this. And you're beating yourself around it. You can spend sleepless nights. You say, what's going on? My pipeline is breaking. Unknown to you, that is the developer's code. But if you don't understand, you will just keep stressing over unnecessary things, right? So another thing is not building in public. You have GitHub profile. You can make LinkedIn posts. You can start building your portfolio from now. Any small thing you're doing, push it to GitHub. Because, of course, there's a way GitHub keeps tracks of whatever you're doing. Push it to GitHub. Start building your LinkedIn. This is something I learned uni. From there, you can see people saying, well done, I need you to do this. I've made a post before and someone say, I think you can also add this to it. And I was like, thank you so much for that. But if you're saying, I don't want to make mistake, I don't want to post something that somebody will not come for me, you won't learn, really. You won't learn. So tutorial hell watching. You're watching tutorial. You can watch tutorial from morning to evening. And you're not building anything. You're just watching the way the guy is running these LSCD, PWD, CATs, doing all of those MV, CP, flag har, MV, whatever. And you're not learning, you're not practicing it. It should just be like a dream, right? Every tutorial must end with a project you deploy yourself. If you watch a tutorial on YouTube and say this person is trying to build a Docker file, have your own on your machine and try to do the same thing. Something will break, of course, and that's how you learn, because every tutorial might not cover everything. But when you start building yourself, you will now start seeing the gaps and say, maybe this person did not actually show this in the video, because there's no how you can actually skip this step. I've watched a tutorial before that the thing was not just working, unknown that a particular step was skipped. So if you don't do this, if you don't build yourself, of course, you start giving yourself a whole lot of headache. You are just watching. You say, I've finished Abhishek video, Terraform, I've finished Docker file, and you've not built anything. Nothing is on your GitHub, nothing is on your portfolio, nothing is anywhere. Ignoring security from day one. Your keys, your tokens, they are flying everywhere. Your env file is on your GitHub. They are just shouting everywhere. It's not good, right? There are ways for you to keep all of this secure. Like the way when you build along with security, because by the time you get into organizations, that habit, you're already used to it. You won't even try to make that kind of mistake, because some organizations, they don't even tolerate it, right? Security is not optional. Try to learn IAM and least privilege as early as possible. Somebody is trying to say, oh, I need some access to your AWS environment or your Google environment, and you're giving them root access, you're giving them admin access, they can do and undo there. Then you know that you're really doing something wrong. Then waiting until you feel ready. I don't feel ready. No, you don't have to. Apply for internship roles. Some might not even be paid, right? It does not have to be paid, contribute to open source, real work equals growth, really. That's it. So I think I'm ready. Joseph, how many times do I have left? Let me check so I can.
I'm sure we are all enjoying the session.
Okay. So sorry, guys. So
7.
if you're enjoying this session, just give me a thumbs up, or I should just give it's at stop. All right, thanks guys. Cloud certification that really matters. So like I mentioned, AWS Cloud Practitioner. So when I took my AWS Cloud Practitioner, it was under ALX, so they took up some price out of it. I'm not sure if that is still active, but you can check them out. So AWS Cloud Practitioner, it's more like help you understand your basics, right? To know what you're doing, right? And like I said, don't just say I want to go and take certification. Try to start building, right, before you start going into certification. Then AWS Solution Architect Associate as well, more like cloud engineering. This one should take you like 2 to 3 months. If you really know what you're doing and you're really in for this, you should learn. There are a lot of resources out there that could help you. I think I still made some videos around this solution architect and cloud practitioner on my YouTube. You can check it out. We have the Google Associate Cloud Engineer. We have AZ 900 for Azure fundamentals, best for enterprise and banking sector. We have CK, we have KCNA. I think KCNA is free. KCNA is free, and that gives you more like a free understanding of Linux. They explain port, they explain service, what service deployment, all of those, your kubectl, namespace, and the likes, right? So also we have the HashiCorp Terraform Associates. This is basically for your IAC, your try to like understand what is Terraform. You can even use Terraform to say, oh, I want to use Terraform to provision an instance. But then if you don't really do that manually to see, okay, this is an EC2 instance and these are the things I need to spin it up, you might not really understand when they are telling you to pass a particular parameter inside your Terraform config file to say, oh, I'm declaring this variable, I'm declaring this, I have to declare my region, AWS this, AWS that, and the likes. You might not really understand it. But first, you might start with going in and use ClickUps. What do I mean ClickUps? ClickUps is just you trying to like click those resources right from there and say, oh, create, delete, deploy, destroy, all of those. But then from there, you graduate to, or you trying to use infrastructure as code like Terraform to provision those resources, right? So, quick one. So, which cloud career path interests you most? You can just drop your answer in the chat, A, B, C, or D. Let me know if you're following. Just DevOps. Okay. Interesting. Data engineering and DevOps. All right. Um, okay, Wendy D. Sorry. Okay. I heard there's it's not really about the money. Okay, dual partition, it works fine. Well, but do you know some people really don't like it because it might not, your system might just start acting. I have to later take the decision of changing it completely. Really. I've not been checking the chats. Okay, ALS is no longer offering. Yeah. I think someone mentioned that. I'm not sure. Okay, so let's continue. Where is my slide? Okay. I think I've stopped sharing.
Yeah, you stopped presenting.
Can you see my screen now?
It's not back on yet.
Okay. Is it better?
Okay. Yeah, now it's back on.
Okay, so the future of, I know a lot of us have been seeing AI everywhere. AI is taking place. You can, in fact, I know a lot of us are using AI, right? Um, so cloud is becoming the delivery platform, right, for all of this AI, and that changes everything. So AI powered infrastructure, cloud providers now offer managed AI services, right? And we have the Amazon Bedrock, right? We have the Google Vertex AI, the Azure Open AI. You don't you don't need a PhD. You just need like cloud skills for all of this. So serverless and edge computing, we have functions that runs on demand. I know you know about serverless. Serverless has more like a different conversation on its own. We have Google Cloud Run. You basically, for serverless, right? You pay only when your code runs. So if it's not running, you're not paying, right? Then we have security at every layer. You know, zero trust architecture. You you just have to like add security at different layers of your development. Then we have the DevSecOps. So this is another role. I know I really didn't mention this, but DevSecOps is more like another role on its own. This is when you integrate security to your pipeline, right? Then compliance as code. You have auditors trying to like review and make sure that everything is appropriate, right? So security is no longer more like an afterthought. It is built into the pipeline. Like you have to like have its security scan. That use maybe check marks, like I mentioned earlier. Use app scans for you. I think I've used OWASP dependency check before just to check for vulnerabilities and the likes. And then you can use your Sonar Cube to check for code qualities, or if there's something that's not supposed to be in your what's it called it in your code. Then we have FinOps and cost intelligence. Cloud spend is under scrutiny, right? Engineers who can optimize costs, that you're just blowing everywhere. You're deploying just a simple application. You have spin up your Kubernetes. You're running a GKE or you're running a KS on top, just a little application, right? Um, more like engineers who can optimize costs while maintaining performance are incredibly valuable. Yeah, that's the point I'm trying to bring out from there. So the key takeaways, right, is this everything you need to remember from today's call, right? Cloud, it's basically renting compute resources over the internet. And don't forget, I also mentioned me referring to cloud as a separate planet on its own. All those servers, right? They need something like to stay healthy. If they don't see this, if they don't see that, they don't function well. Just the same way as human, we need food, we need water, we need animal, we need plants to live. A lot of components comes in together to make your application what you're seeing out there today. So every app you love, whichever it is, right, runs on cloud infrastructure, whether you like it or not. For you to be able to access it, and you don't even know who built it or where it's coming from, it's definitely running on cloud. So there are like 6+ career paths in cloud, not just one. So find the one that fits your interest, what you feel like, oh, I think I love DevOps. I think I want to move into platform engineering. I think I really love this security part of things. I want to start helping. I want to start working on integrating security into DevOps pipelines, not just you building pipelines, but you're also building security into it. Then start with Linux plus networking. Don't just jump into Kubernetes from zero knowledge, right? Then one cloud provider, not just all cloud provider. I know you want to understand AWS, you want to understand GCP, you want to understand Azure, you want to understand UAU Cloud, but trust me, if you pick one and you understand how it works, right, you can apply that knowledge across board. You just need to understand what Google is saying. You just need to understand, oh, instances, oh, secret manager, oh, cloud run, oh, GKE, oh, this and that to get certification and build projects. Start building your portfolio. When you're learning, push it there, you know, keep notes, document. For me, I'm very, very big on documentation. Whatever I'm doing, my day-to-day activity, I'm documenting. Cloud plus AI is the future. The skills you build today will compound for years, right? Then lastly, you don't need to know everything. You just need to start somewhere and keep going. So yeah, thank you so much for having me. And you can connect with me, Eunice Adediran. Just if you call me Adeniro, I'm Adediran. Okay?
So sorry
So
about that.
yeah, that's fine. So my LinkedIn, Eunice Adediran, GitHub. And yeah, thank you for being here. Now go and build something.
All
I think
right.
I can stop sharing now.
Yeah, you can. You can. Okay. I think what follows is the Q&A session. If anyone has, a question to ask of our industry experts. I mean, if you are really going to be going down this line, you may not get any other chances to, converse with someone that is already in the space. Of course, we'll be dropping the links to, connect with Alvin after this. Any questions? Okay, so while we wait, let me ask,
Guys, ask questions. Ask
yeah,
questions, please. Ask questions. Let's ask questions.
all right, okay, someone, Adi Bulwatife.
Yeah. Do you want to go first, Joseph, or you want her to go first?
Yeah, she can go first.
Okay.
Hi, good evening.
Yeah, good evening. How are you doing today?
Yeah, I'm good. Thank you. How are you too? So my
I'm
question is
fine.
that I actually already have a roadmap that I'm following now, but how do you learn in a way
Okay.
that it does not feel like what you're learning it in isolation? Because I always hear people advise that make sure that whatever you're learning, you can be able to like put it together and know how they run. I've not really gone
Mm,
so far because I just started like 6 weeks ago, and I'm just learning the fundamentals on like Linux, version
mm.
control, Git. I've not really gone in depth into like major cloud tools or like all these containers and orchestration. But I
Yeah,
that
yeah.
time I just want to know how I can like learn it in a way that I'm not just like learning it singularly that, but in a way that I can like bridge everything together and make sure that I actually understand it well.
Okay. Thank you so much for that question. Right. So I think I mentioned it, right, that don't try to learn everything at once. And I think you're really doing well. Please, for a start, Linux, networking, try to understand those. Do you have a GitHub account?
Yes, I do.
Do you have any writing tools that you use, maybe dev.to or Medium?
No, I've not started writing articles yet.
Okay,
But I have
so
account.
one of those things that helped me is I document as little as it might be, right? Try as much as possible to write as you're learning, because you'll be surprised that one day you just get stuck and be like, okay, I think I've read about this thing, I can't just remember. And your article will be what will remind you. So you can, the basics that you're learning now, maybe you're learning all those normal commands that you use, maybe ls, pwd, or try to understand what's ip, dns, and the likes. Try as much as possible to write about it. It does not have to be perfect. Like, you don't have to be perfect about it. I look at my writings like years back and I'll be like, okay, I think I should have done better. What kind of image is this? But then that really helped me because I started from somewhere. So don't try to like learn Docker now. Don't try to learn Kubernetes. Like I said, you might even be watching Linux video and they are just bringing Kubernetes to you and say, recommended, watch this one, watch that one. Just be focused, right? Just be focused. Finish with what you're doing. If you're taking 2-3 months to learn Linux, finish it up. Understand it. If you have questions or anything, you can just go online to read about it. If you're still not convinced yet, right, you can reach out to me, right, and we
Yeah,
can have a
thank you.
conversation around it. Yeah, that's
Thank
fine.
you.
So, but then don't try to learn everything at once. Start with that. It might look as if you're lacking behind. Don't even feel that way, because by the time you're done, you will hear somebody talking about Docker file orchestration, and you ask them a simple question, like just a simple basic question, and they can't answer it, and that's what's going to differentiate you from that person. So yeah, that's my take.
All right. Any other questions from anybody? Just raise your hand.
Ask
In
questions. Oh. I'm waiting for your first deployment, your first broken pipeline,
the way.
guys.
So okay, let me ask mine while we wait. I guess mine has to do with, let's just say, the overwhelming axis, let's just say job security in cloud. Because as I know now, like, there are literally AI, like, I don't know, lovable and sites that you can just prompt your way into building a fully functional site.
Mm.
So is there, how do you see it's going to progress? Like, do you think you're going to be able to prompt your way into this massive infrastructure, like writing Terraform code that will provision all of this and connect them on the instances and whatnot? And also, I guess you could also show insight into how you use AI in your own day-to-day work.
Mm. Okay. So I think what people really don't understand with AI is they feel like AI is just here to do your job. But one thing about AI is you have to tell it what you need it to do. So if AI is helping you to do something and you don't understand that thing, bro, it is well. That's just what I'm going to say. So even if you're saying AI, fine, AI is here, right? But then AI is here to help you with what you're doing, with your work. It's not here to take your role. It's not really here to say, okay, you have to, if you notice, right? If you don't give AI the correct prompt to do something for you, you won't get the right answer. I've seen people saying, oh, Eunice, how do you design all this, your flyers, all this, your this? If you don't give AI the right prompt, it's not going to deliver what you need it to deliver, right? So that's one. I really want to clarify that. So AI is there, yes, fine. But then if you ask AI to go and provision something for you and you don't understand, and you're working in an organization, you're already hired, and you went ahead and break something, just say, AI, no, that's not what I'm saying. No, you have something is not working again. Please revert those changes. That's when you know that you can't do it with your basics. You just need to understand what you're doing. Because that guy will tell you, I'm not perfect to validate whatever I'm giving you. Right? So you really need to know it, right? Before you even say, oh, you want to use AI. I've used AI before and I'll be like, no, bro, that's not what I need. That's not what you're giving me. This is not what it is. But if you don't know, you just keep circling, and before you know it, God will help you. You're using free ones. Just tell you that you can't proceed from here. You need to recharge. Okay. And you are in the middle of a critical problem. So what will you do? You say come back by 3 p.m. or 4 p.m. or tomorrow morning, and you need to deliver. So Joseph, I hope I answer your question.
Yeah,
All
that's
right.
one.
So any other question?
Any other questions? Don't worry.
If
Okay.
I almost called. Okay, this is similar. Okay,
Yeah.
similar.
Hi, good evening. So my question is, I I don't know. I usually see, I've kind of had some few experience with developers, and most of them don't necessarily interact with cloud services like that. And so, like at what point do, because usually they either deploy maybe on Netlify, Vercel, and all of those platforms, and
Mm.
then at times I just wonder, like, at what point then do you need all of these cloud services, like, since we already have other platforms that has literally set up the infrastructure you need, to host your, or to either to host your, what's it called, your site or your workload, all of those kind of things. I don't know if you answer my question.
No, really. Can you take that again?
Like, I'm saying that at what point, like, I've seen developers that have built like applications, right? And
Mm.
they didn't necessarily interact with cloud services to deploy it, to host it or to deploy it. You get what I'm saying?
So
And then,
how do they? Sorry. So you're saying they don't really
so like,
use any cloud
yeah, like they don't,
service?
yeah, they don't use like the AWS. It's not like they set up all this. They
Okay.
don't set up infrastructure. They don't do all of those stuffs, right? And
Yeah.
yet they have the applications, running and all of those kind of
Okay. You're
things.
talking
And in fact,
about
they can have
Netlify.
actual users use them.
You're talking about Netlify and
Yeah,
quite a lot of
Vessel, all
them.
of those kind of things. Yeah.
So next. Okay.
So, like, since we have those ones, what's now the point of like AWS and all of these cloud service providers?
Mm.
Like,
Mm.
what's the point of setting up when we already have platforms that have done the work already, the whole infrastructure work?
So one thing I want you to know is, first of all, that's actually a great question, right? So you see platforms like Vercel, Netlify, you have Render, all of those, they're actually built on top of cloud infrastructure. That's what you don't know. So is either you're on cloud or you're deploying to cloud or you have your services running on your local machine. It's just those two ways. So think of it more like um if you kind of book a ride through Uber, right? You're using transportation without owning a car. So it's more like similarly when you deploy to Vercel, you're using cloud infrastructure without really managing the infrastructure yourself. Do you understand? So the difference is just the level of control. Platform like Vercel and Netlify, they kind of abstract away the infrastructure, like making deployment easier for developers. Do you understand? But as application grows in complexity, in scale, security, requirements, or cost consideration, organizations usually often move closer to the underlying cloud platforms like AWS, Azure, or GCP to gain more control and flexibility. Do you understand? So it is not really Vercel versus AWS or GCP. Vercel is actually helping you consume cloud services in a simpler way. That's just the thing. Hope I'm able to answer your question.
Yeah,
Yeah.
you answered it. Thank you very much.
All right. You're welcome. So any other question for me, guys?
Any other questions? Any other questions? You guys can ask away. And if you are too shy to ask it on the call,
Don't be shy, oh, don't be shy.
Don't be shy.
we'll be leaving links where you can directly contact okay.
Fine.
Inab Inanabo.
Yes, good evening. Can you hear me?
Yeah, good evening. Yes.
Good evening. I really appreciate you for making a time to give us this lecture. Yeah, you talked about cloud, and I think this group is about cloud and AI. So I have passion for AI and also same passion for cloud. So how do I possibly combine the two? And knowing very well there are different career paths in both of them. There are different career paths in cloud as you shown to us. So there are different career paths in the AI. So how do I combine these two? Thank you.
Mm. Okay. Yeah. Siri, I can't hear myself. I don't know why that is. Okay, let me just proceed. So honestly, right, cloud and AI sort of like complement each other. That's just what I want to say. So most modern AI solutions are actually powered by cloud infrastructure. If you get that. So when you like train a machine learning model, store large data sets, deploy an AI applications, or expose an AI model through an API, you're usually using like a cloud service underneath. That's just the truth. So you don't necessarily have to choose between cloud and AI immediately. You can just start with cloud fundamentals, right? And then later on decide how deeply you want to move into AI. So if you really want to move into AI, you can focus in. If you want to move into more like AI engineering, you can focus more on like Python, machine learning, deep learning, data science, and modern development. Do you get? But when it comes to like cloud engineering, you can now focus on the infrastructure, right? The networking, the security, the containers, the Kubernetes, the automation, and the cloud platform itself. Then there's also what's it called itself? That's MLOps engineer that kind of comprises of both. That's the cloud plus AI. So this is more like where both of them meet. So MLOps engineers help deploy. They help to also scale and monitor. Then they also automate AI models in production environment. Do you understand? So you'll be using tools like Kubernetes, you'll be using tools like Docker, you'll be using CI/CD as well, GCP, Azure OpenAI, and the like. So if you're genuinely enjoying both cloud and AI, I would basically just recommend building a strong cloud foundation first for yourself, right? Then you gradually learn AI concept and Python. And over time, you can now move into MLOps, AI infrastructure, or cloud AI engineering, whichever suits you. So, which are somehow of the fastest growing areas in tech today. So, it's basically based on your decisions moving forward. Yeah. I hope I'm able to answer your question.
Yes.
All
Thank
right.
you.
You're welcome. So, any other?
Any other questions?
I think we are all good.
Yeah, I think we're all good. So, okay. First is first. I think we should thank Eunice for we should thank Eunice for this session. Just like drop some clapping emojis. Just drop some clapping emojis. I'm sure she really tried. She spoke for over an hour, and first is first. Like she took time out of our busy day. DevOps engineers are really, really busy people. Like it's not easy to make that money. They have to be infrastructure provisioning and all of that. So yeah, Eunice, we are really, really appreciative of you taking the time to set us on the right track to, become full DevOps engineers. And okay, so this meeting was being recorded, so we'll be uploading um the full the full session to our YouTube channel. I'll also be working uh on a kind of like summarized version, if that'll just be a few minutes for people that want to like grasp the entire thing. And along with that, the links the links that I promised to share for any of us not on the GDG OAU cloud community group, I'll be dropping the link in the chat for us to join in and get familiar. On that group, I'm going to be dropping the links to contact the speaker in case we need to ask more questions and any other thing. And I guess that's really all that we have for today. And I'm sure you guys managed to have some really wonderful takeaways from the entire session. Like I said, this is the first of many sessions, so you guys should look forward to what else we have in store. And with that, we are rounding up. Thank you very much, everybody, for coming. Thank you to our dear speaker um, for joining in, and thanks to every one of you that asked questions and made the session engaging and interactive. Thank you all very much. Have a nice Sunday evening.
You too. Thank you.